Hello everyone, let's discuss about subroutine in this session. So subroutines are nothing but subtasks which we want to execute it many times on the different data values. For example, we have written a program in which a part of the program may be a task, it want to be executed repeatedly on different values, and that subtask is called as subroutines. Instead of writing that subtask in the main program repeatedly, we will make a copy of that program. It will be stored in the memory. Whenever we want that task to be executed, the program can branch to that subroutine and it can execute that subroutine and it can come back to the main program. Therefore, we say the main program will be calling the subroutine. So calling the subroutine is nothing but it will be done by an instruction called as call instruction. So the calling program will use a call instruction to call the subroutine, and once that subroutine has been executed, it has to come back to the calling program, nothing but to the main program. So this is the general representation of the program, calling program and subroutine. So here you can see we have used a subroutine by the name SUB. So once we are calling this sub, so it will go to the location, that is the where the first instruction is stored. So the subroutine's first instruction is stored in the location 1000. Therefore, it will move there, it will execute the instruction, and once that subroutine is been executed, now it has to return to the calling program, nothing to the main program. Now the question is, once it is returning to the main program, from where it has to continue its execution, whether it has to start from the beginning or it has to resume soon after the call instruction. Now the answer is yes, it has to resume the execution of the main program soon after the call instruction. Therefore, once we are moving to the subroutine, we have to save the content of the program counter with the address which is soon after that call instruction. So here you can see we have the address 200 where we are switching, where we are branching to the subroutine. So once that subroutine has been executed, we are saying return to the main program, where we have to continue our execution soon after call instruction. So soon after call instruction means the location where that instruction is stored is 204. Therefore, before we are moving to the subroutine, the content of the program counter has to be saved. That is, it has to be loaded with 204 so that once the subroutine is executed, we can come back to the main program and we can continue the execution from the location 204. We use a subroutine linkage method which makes us possible to call and return from subroutine. So this is the subroutine linkage using a link register. I said in the previous example, the program counter should be loaded with the value from where we have to resume the execution. So the location where we are supposed to supposed to resume the execution was 204. Therefore, before we are moving to subroutine, the PC should be loaded with the value 204. That is, this is the address where from we are returning from. If we are returning from subroutine, we have to continue the execution from the location 204. So this register, what we are using, link register, it will make us possible between the calling program and subroutine program. So this is the subroutine linkage using a link register. You can see this is the subroutine side where the subroutine has been executed and we are saying return to where 204. So and this is calling program, right? The calling program side, the calling program is storing or saving the contents 204 on program counter before switching to the subroutine. Therefore, this switching between calling program and subroutine makes it possible by the help of subroutine linkage method. We are saying call instruction, it is a special branch instruction which will perform like, first it will store the contents of the PC in the link register, then it will branch to the target address specified by the instruction. Whereas the return instruction is also a special branch instruction which will perform branching to the address contained in the link register. So the link register will be holding the value from where we have to continue our execution, from where we have to resume our execution. In this case, we have taken 204. So call instruction, it will perform storing the contents of PC in the link register and branch to the target address specified by the instruction. Now when you are said call sub, so this sub was stored at the location 1000, right? Similarly, when we are saying return instruction, which is also a branch instruction, which will perform branch to the address contained in the link register. So now link register is holding the value of 204, from where we have to continue our execution. Next we have subroutine nesting, nothing but calling a subroutine inside a subroutine. Just now we said we will be having a calling program and we will be having a subroutine, right? So we have a calling program, and in that we are saying call sub, right? And after this you will be having a next instruction. So now we have to store the contents of the PC in the link register. When we are saying sub, I will say sub 1, so that this calling sub 1 makes me to go to the subroutine sub 1. Now if inside this sub 1 I am using one more instruction saying call sub 2, call sub 2. So now when I said main program, nothing but calling program, inside the program I had the instruction call sub 1, which makes me to branch to sub 1. When I am executing this sub 1, inside this sub 1 I am using one more subroutine, that is saying sub 2. So now when we are returning, so first we have to return from, right? So okay, so sub 1 is there, you are saying sub 2, right? Calling sub 2. When we are saying calling sub 2, we have to go subroutine 2. Now we have to execute the program, then it will be return. From where we have to return? We have to return to sub 1, again return. From here we have to return to the calling program, right? So we had a calling program. Inside the calling program we called one subroutine. When we have branched to the subroutine 1, again we are trying to call one more subroutine, that is subroutine 2. So now from subroutine 2 we have to first return to sub 1, and again from sub 1 to we are supposed to return to main program. And again when we are moving from one subroutine to another subroutine, first we will be moving from main program to subroutine 1. So we have to save the contents in the link register so that we can resume our program execution. When we are moving from sub 1 to sub 2, again the return address has to be stored, again which will be stored in link register, which will delete the present content. Therefore, now when we are using subroutine nesting, we will go with processor stack, which will work on last in first out, where we will be storing contents of the PC onto the processor stack. Here when we are saying the call instruction, it will pushes the contents of the program counter onto the processor stack and loads the subroutine address into the PC, whereas the return instruction pops the return address from the processor stack into the PC. So next we have parameter passing. When we are saying parameter, it means with the data are nothing but the operands and their address. So when we are calling a subroutine, the program must give these parameters to the subroutine so that it can perform the computation. Whereas the subroutine will return the other parameters, which are nothing but the result of the computation. So this exchange of information between a calling program and subroutine is referred as parameter passing. So now this is the example we have taken between the calling program and subroutine switching. So hope you remember we have done a program for adding the n numbers and storing the result in R0. Storing the result in R0. We will be using a pointer to say about the different location where the data is stored, and we will be using R1 as an counter. So now we are using three registers, R0 to store the final result, R1 which is acting as a counter, and R2 it is acting as a pointer. Now instead of writing the whole program, what we have done in the calling program, we have done the initialization, this one to say how many numbers you need to add. This instruction is saying, that is, you are loading the location of the first number into R2. Next we are saying call list add, where list add is nothing but your subroutine. List add is your subroutine. Now you can see we have switched to subroutine list add, where initially we are making R0 is equal to 0. Then every time we are fetching the data which is indicated by R2, we are adding with R0 and storing back the result in R0. Now after every addition you are decrementing R1. If your counter is greater than 0, then you will loop back. So loop back, perform the same additions. Once the counter is becoming 0, then you have to say return. Where you will return? You will return to the main program. Where in main program? Soon after the call instruction. So the soon after the call instruction, it is saying move R0 comma sum, nothing but the result which is stored in R0 will be moving into the sum. So this is the program what we have already written, adding the n numbers. Now we are writing the same program by using subroutine. So this is the main program, nothing but your calling program, and this is your subroutine, where R1 is acting as a counter, R2 is acting as a pointer, and R0 is used to store the final result. Now this is to say the number, how many numbers you need to add. This is to point your address, and the subroutine what we have used is list add. When we are saying call list add, we will be switching to the subroutine. Now before we are switching to the subroutine, we have to save the content, nothing but the address of the next location in the link register, so that when we are returning, we can easily return to the instruction soon after call. So when we are switching to subroutine, we will execute this set of instruction where R0 will be initially 0, so that we can keep on storing the temporary result, intermediate result. So this instruction will keep on fetching the data which is pointed by R2, and it will be added with R0, and it will store back the result in R0. After every addition, R1 will be decremented, and it will be checked whether it is greater than 0. If it is greater than 0, then you will be looping back, and you will execute this set of instruction here till branch. Once this counter is becoming 0, you will say return, where you will be returning to the instruction soon after call. So this is the parameter passing which will be used with respect to calling program and subroutine.